In this course, you'll need to be familiar with the standard international units of measurement for several quantities, and particularly for length, mass, time, temperature, and amount of substance. You'll want to commit the unit, SI unit, and their symbols to memory. Length, the unit that's commonly used is meter. Standard unit for mass is kilogram. Second for time. Temperature is in Kelvin. And the standard international unit for amount of substance is a mole. The symbols associated with these are lowercase m for meter, kg for kilogram, S is for seconds, Kelvin has a symbol K, and then the mole is abbreviated MOL. So please make sure you've committed these units, SI units, and their symbols to memory. In addition, you should commit to memory these metric prefixes that are used to modify the SI units and their associated factors. So in other words, the factors which show how much each particular prefix modifies the SI unit. As an example, microsecond, this would be written as μs. Micro, we see in the table, has a factor associated with it of 10 to the minus sixth, so 0.000001. And so it modifies the SI unit second by 10 to the minus sixth. So microsecond is equal to 10 to the minus sixth seconds. Another example, kilo modifies meter by 1,000, a factor of 1,000. So a kilometer, which would be written km, is equal to 1,000, or 10 to the third meters. So by using the prefixes and their symbols, along with the symbol of the SI units, we can create smaller or larger units of measurement, and this is done based on convenience depending on the size of the measurement we happen to be making or the calculation. If we look at these factors, we see lots of zeros. Those are kind of hard to memorize. It's much easier to memorize the factor associated with each symbol. In other words, how much mega or kilo or hecto modifies the SI unit. It's much easier to memorize those in scientific notation. So if we move the decimal place over 12, we get in scientific notation 10 to the 12th for tera. It's much easier to memorize 12 associated with tera than have to worry about all these zeros. And likewise for giga, we have 10 to the 9th. Mega is 10 to the 6th. Kilo, 10 to the 3rd. Hecto, 10 to the 2nd. And for the smaller prefixes, deci is 10 to the minus 1, centi 10 to the minus 2, and so forth. Down to nano, which is 10 to the minus 9th. You should memorize, again, be familiar and have at your fingertips these factors along with the symbols for the prefixes so that you can use them quickly and easily in calculations. There are also SI derived units that are used for various quantities. SI derived units. So for instance, for velocity, which is distance over time, the SI derived unit is meters per second. Notice that these units come from our standard international units for length and time. For area, meters squared. Volume, meters cubed. And for density, density is mass over volume. SI derived unit is kilograms per meter cubed. So kilograms and meters cubed. For some of these, though, some non-SI derived units are more commonly used, particularly for volume and density. So non-SI derived units. These, however, sort of more commonly used, and work well with the SI system, and in particular liters for volume, and for density we often use grams per liter or grams per milliliter. These non-SI units work well with the system, as I said, and we can show, for instance, with a liter, how it's related to the SI units. So for instance, a liter. Liters are defined as a cubic decimeter. So 1 liter is equal to a cubic decimeter. This is a decimeter is related to centimeters by a tenfold. So cubic decimeter would be equal to 10 centimeters cubed. And therefore our liter is defined by a cube that has 10 centimeter sides. Each side is a length of 10 centimeters. This defines the liter. And we can relate then the liter to our SI unit, which was meters cubed for volume. So relationship to SI unit, which is meters cubed. In order to do that, we'll take the 10 centimeters cubed and multiply by conversion factor, converting from centimeters cubed to meters cubed. If we look over in the table, we see that centimeters are related to meters by 100-fold. In other words, 10 to the minus 2 in this case. So there will be 10 to the minus 2 meters per centimeter. Now, we have a volume in centimeters cubed, so this also needs to be cubed. So we need to cube the whole conversion. So it would be 10 to the minus 2 meters per centimeter, and that conversion factor cubed. And so this produces 10 cubed, centimeters cubed, okay, which is our liter, times 10 to the minus 6 meters cubed per centimeter cubed. And now centimeters cubed cancels out, leaving us with 10 to the minus 3rd meters cubed. Therefore, our non-SI unit, the liter, can be related to our SI derived unit, and 1 liter is equal to 10 to the minus 3rd meters cubed. And shown here, we also use the metric prefixes to modify units such as a liter, these non-SI units, in the same way we did with the SI units. So M in front of L produces 10 to the minus 3rd liters, the relationship there. Microliters would be 10 to the minus 6 liters, and so forth.